Yeah, shalabala. Okay. This is the test review for the chapter test you're going to be doing. And number 1. So they want us to simplify the square root of 20. And the way I would simplify the square root of 20, this is with a narrative, but I'm going to do it kind of fast. What I would suggest is rewrite it so you're talking about the square root of 4 times 5. Now you could have said 2 times 10, but 2 or 10. Like if you wrote it as the square root of 2 times 10, none of those are perfect squares. You couldn't take the square root of anything. But if you write 20 as 4 times 5, you know, even though you cannot take the square root of 5, you can take the square root of 4, which is what?
2 times
2. So the 4 comes out and becomes a what? 2, and the 5 stays, and that is done. Number 2. Number 2, you have the square root of 306 over the square root of 204. Is it showing up on that thing? Okay, good. Now, I don't know about you, but when you have a square root on top and a square root in the denominator, you could write it as a single square root, and you could write that as a square root of 306 over 204, and you got to reduce it. When you reduce it, and by the way, you know your calculator reduces very nicely for you. It actually reduces to
The whole answer.
3 over 2. The fraction reduces to 302, but there's a huge problem with that. You got a square root in the bottom, so you're talking about the square root of 3 over the square root of 2. That would be fine, except you cannot have a square root in the denominator. The only way to get rid of that is to multiply by whatever it is. But if you multiply the bottom, you multiply the top, and the numerator becomes the square root of 6, but the denominator becomes the square root of 4, and what's the square root of 4? 2. So that would be fully simplified. Notice I copied the problem, I numbered the problem, and I'm showing my steps, and I circled my answer. That answer would go in the space on your answer sheet, number 3. In number 3, they're asking you to solve this quadratic, which is 3x squared minus 9 equals 3. Notice it's a quadratic because the highest exponent is a 2. However, the linear term is missing. And when the linear term is missing, just solve it for x squared. The 9's cancel out, so we're talking about 3x squared equals 12. Divide by 3 on both sides. The 3's cancel out, and you're left with x squared equals 4. Now how do you get rid of x squared?
Square root.
Square root, but if you take the square root of that side, you've got to take the square root of this side. However, I got to also add the what? You can answer, you know. Plus or minus. So the square root of x squared is x. And plus or minus the square root of 4, which is 2. 2 answers. Hello. Number 3. That's the answer. Copy the problem, number the problem, showed my work, circled my answer. Number 4. Number 4, they want you to simplify. Well, you got the square root of 6 all over 4 plus the square root of 2. And you know, there's not much to simplify.
So you're gonna do 46.
But however, you are not allowed to have a square root in the denominator. And you can't just multiply by the square root of 2. You put a parenthesis around that, and you're going to multiply by its, what you get?
Conjugate.
Conjugate. So you're talking about 4 minus the square root of 2. So help me, if you multiply the denominator by 4 minus the square root of 2, guess what you got to multiply the top by?
Same thing.
Exactly. Now, the numerator becomes the square root of 6 times the quantity of 4 minus the square root of 2, which I'm going to distribute momentarily. But the denominator, you got to use FOIL. It's full factoring. You start with the 4 and you multiply the 4. But you continue and you multiply the 4 times the negative square root of 2, which is really minus 4 times the square root of 2. And then once you distribute the 4 to both of these two values inside the second parentheses, you kick in with the square root of 2 and you multiply, you distribute to both values inside the second parentheses. So you say the square root of 2 times 4, which is actually plus 4 times the square root of 2, and then the square root of 2 times negative square root of 2. Well, positive times negative is negative, but what's the square root of 2 times the square root of 2? And we know it's just a 2. Because whenever you multiply a square root of something times the square root of itself, you just get that value. Because the square root of 2 times the square root of 2 is the square root of 4, which is 2. Then the beautiful thing about this is those middle terms cancel, because negative 4 square roots of 2's plus 4 square roots of 2's, ideal square root. And then in the numerator, you can distribute now. So in the numerator, we're talking about 4 times the square root of 6 minus the square root of 12. And then 16 minus 2 is just 14. You would think you're done, but you're not. Because you could simplify further. However, the main thing is you did get rid of the radical from the denominator. But look at the square root of 12. Do you realize the square root of 12 is not only 2 times 6, but it's 4 times 3? Why did I prefer 4 times 3 over 2 times 6? Because 2 times 6, none of those are perfect squares, but I can take the square root of 4, not the square root of 3. So if I take the square root of 4, that comes out and becomes a what?
2.
So I'm left with a 2 times the square root of 3. So I'm going to replace that, and it looks like this. Check this out. I got 4 times the square root of 6 minus 2 times the square root of 3, all over 14. And when you can factor out a common factor, like what goes into 4 and also into 2, 2. That would be 2 times the square root of 6 minus just the square root of 3. Think about it. If I redistributed the 2, what's 2 times 2?
4.
And then 2 times the square root of 3 is that. It's still over 14, but now I'm in a position where I could reduce by saying 2 goes into 2 once, and 2 goes into 14 7 times. So 1 times all that is just 2 times the square root of 6 minus the square root of 3, all over 7, and that is what I'm looking at. Right dough, that dough. Y'all see that in John? And number 6. No, 5. Hello. Number 5 is kind of a giveaway. I shouldn't say that. I don't mean to be flippant, but they're asking you in this complex number in standard form, they're asking you to identify the real number part, and that would be the -7. The imaginary number part is the number that's in front of the I, which is going to be -5. Not the I itself, just the number, the coefficient. And that's number 5, 2-parter. On your test, if you get one wrong, I'm not giving you any credit at all. You got to get the whole thing correct. So I'm flipping over the paper. And number 6. In number 6, they're asking you to take 4x squared. I'm sorry, I lost it here. Oh, yeah. Plus 20 equals 0. Now you got a quadratic, but it's also missing the linear term. So just subtract 20 from both sides. And you get 4x squared equals -20. Divide by 4 and divide by 4. The 4's cancel. We're left with x squared equals -5. How do you get rid of that squared? Square root that. But you got to do plus or minus the square root of that side. So we get x equals plus or minus the square root of -5. You got a huge problem. If you leave your answer with a negative inside the square root, not a mercy. You've got to remember that the negative comes out and becomes a what? So it's going to be plus or minus I times the square root of +5. And if you could take the square root of 5, do it, but since you can't, just left it. Leave it alone, that's perfect. And number 7. Number 7, it says right the answer, the expression of the complex number in standard form. Well, guess what? We have -2 plus 4i minus the quantity of 3 plus 9i. Keep in mind that you just deal with the I like it's a regular variable, x. Order of operations states do what's inside the parentheses. There's nothing you can do in there, nothing you can do in there. So remove the parentheses, nothing is multiplying it. So you got -2 plus 4i. And before you remove those parentheses, you've got to distribute the negative. So what does that all become? -3 minus 9i. Collect like terms. You got a -2 and a -3. Same add, difference, subtract. So what does that give you? -5. And 4i, take away 9i's, which is going to give you -5i. And that actually is the correct answer because it is in standard form. Remember, standard form is a plus bi. Circle your answer. You're good. To remind you, I squared equals -1. I itself equals the square root of -1. So keep that in mind for the next problem, which I'm glad you asked about. So 8 says you have 3i times the quantity of 6 minus 5i. So you distribute like regular old variables and regular old multiplying polynomials, but 3i times 6, that's just 18i. But 3i times -5, well, that's -15i squared. First of all, you're not going to do anything with this, but I squared is the same thing as -1. So we're talking about -15 times I squared, which is the same thing as saying -15 times what? Okay, I'm going to write it out just in case you get all upset with me. That's what you're talking about. But really what you should have is 18i plus 15. Because -15 times -1. But if you leave your answer like that, you're getting no credit at all. Because standard form states the real number part has to go first, the imaginary number part goes second, and now it's an a plus bi form. Y'all see that in John?
Why
Okay,
did you flip the 15 to,
because the number
real
goes
number
first,
can't go
the
first.
real number part goes first,
and then,
the imaginary number part goes second. It's gotta be an a plus b, that's called a plus bi form, standard form of a complex number. Number 9. You ever do number 9 in John?
number 8.
You want me to do number 8 again? Okay, here's number 9. Number 9 has a product of 2 binomials. The first binomial is 2 plus 3i, and it's times the quantity of 1 minus 4i. Some teachers call it foiling, but you're going to distribute the 2 to both that and that. So we're talking about 2. 2 times -4i is -8i. And then we're done with the 2. Now we do the 3i. So 3i times 1 is plus 3i. 3i times -4 is minus 12i squared. Now, 2 things are going on. You could collect those 2 like terms, and I squared is the same thing as negative what? -1. So we got 2. -8i plus 3i, same add, different, subtract, or different. Subtract, you get a 5. Take the sign of that large number. Now, -12i squared is the same thing as what?
Plus 12.
Yeah, because -12 times -1 is plus 12. So if you could add the 2 and the 12, you're going to get 14 minus 5i, and that is in standard form. Circle it, you're done. Number 10. Number 10. Number 10, they're asking you to write this in standard form. The major problem with this is you've got an I in the denominator. I is irrational. Rationalize the denominator. All you gotta do is multiply the denominator by I. But if you do that, you gotta promise to multiply the top by an I. So I put a parenthesis around the top, and I multiply by I. Distributing the I.
Bless you.
Oh, y'all make me sick and joke. Okay, so here. I times 3 is 3i, and then I times 3i squared is minus 3i squared. Now, what happens in the denominator? You get 4i squared. Cool, because you know what just happened? That I squared is really -1, so we're talking about 3i. Oh, by the way, what do you think I'm going to do with 3i squared?
Negative.
Well, since I squared is -1, what's -3 times -1?
3.
So it's just plus 3. But in the denominator, what happens to the 4i squared? That's it, -4. Now, I'm going to tell you what I was told when I was your age in Algebra 2. When you got a negative in the bottom, get rid of it, put a parenthesis on the top, and put it on the top. And distribute the negative. So it becomes -3i minus 3 all over 4. That's going to get you no credit because it's not standard form. First of all, you got to switch the order so the I goes last. So we'll put the -3 first, then minus the 3i, and it's over 4. But that's not still not standard form, so we're going to separate those. We're going to call it -3 over 4, and that's a minus sign, so I'll put -3 over 4, but it's being multiplied by I, and that's the answer. That's how it should look. I just separated those.